stop everything right now. Just stop. Stop right now. Look, I have 35 different AI agents powered by machine learning and neural networks. Things that you use in your house every single day. This blew my mind when I found out because I really wanted to know. And because I want to know, guess what? You're about to find out. And these devices and agents and networks and things are making autonomous decisions about our life. And I'm not talking about ChatGPT. I'm not talking about Claude Code and Claude Cowork, any of those things. I'm talking about the invisible AI workforce that learned your patterns, trained on your data based on what you give it, the input, and is making decisions without asking permission. The only thing you have to do is look and say, oh, yep, is that what it is? Great. All right, so we're about to get right into that. And thanks for coming along. All right, so here's what most people don't understand about 2026. The AI revolution or renaissance isn't happening in ChatGPT. It's happening in your thermostat, your car, your phone. These are agentic AI systems, meaning they use machine learning to understand your world, your data, your input, your actions, neural networks to make decisions, and deep learning to get smarter over time. So, what makes something agentic? Let's find out. So, let me break this down. Machine learning, machine learning, they learn patterns from your behavior. You have neural networks. They process information like a brain. All right, we have autonomous decision making. They don't wait for your permission. All right. And then we have continuous learning. Continuous learning. They improve themselves constantly. And yes, every single one of these uses the same fundamental technology as ChatGPT or Claude or anything for that matter, just applied differently. So let me show you 35 you interact with daily. So first up, we have smart home ML agents. Your home is a neural network factory. Your smart thermostat, like your Nest thermostat, or any thermostat for that matter, but we're just going to talk about smart devices. Your Nest thermostat isn't following a schedule. You programmed it. It's running a machine learning model trained on months of your behavior data. It predicts when you'll be home using pattern recognition algorithms, analyzes weather data through neural networks, and makes heating decisions using reinforced learning, where it gets rewarded for saving energy while keeping you comfortable. That's AI that literally learned your lifestyle, not programmed, learned. All right. The next is a robotic vacuum and vacuums in general, but we're going to stick to the smart things first, right? All right, so your Roomba uses SLAM, which stands for simultaneous localization and mapping, a machine learning technique where neural networks process sensor data to build a map while navigating it. It's making thousands of micro decisions per second about where to go next, learning which areas need more cleaning, and optimizing its path using the same pathfinding algorithms used in self-driving cars. Imagine a car as a vacuum using the same patterns. But it's true in so many ways. All right, the next up, smart doorbell. All right, computer vision agent. Right, so this agent runs a convolutional neural network, the same architecture used for facial recognition everywhere. It was trained on millions of images to detect faces, recognize familiar people, and identify suspicious behavior patterns. Suspicious behavior patterns. Every frame gets processed through multiple neural network layers, making real-time decisions about, is this a person? Do I know them? Should I alert? All right. Next up is smart security systems. Pattern recognition agent. Your security system learned what normal looks like for your home. Using unsupervised machine learning, it built a model of typical patterns. When you come and go, which doors open when, even your pet's movements. When something breaks that pattern, that's when it alerts you. It's not following rules, it's detecting anomalies from learned norms. All right, number 5, we have smart lights, behavioral prediction agents. Smart lights use temporal pattern recognition, a machine learning technique that analyzes time-based behaviors. They learned when you typically wake up, when you watch TV, and when you go to bed. They're not just responding to motion sensors, they're predicting your needs based on time of day and learned routines. All right, and we're going to run through a few more just so you can just get the gist and really know what's around you and how you've already been using agentic AI devices, systems, all of these things that we think is just now coming about. We've been using it. So here's an idea. Smart sprinkler. Your smart sprinkler machine learning optimizes watering based on soil moisture, patterns, and weather predictions. All right. Garage door uses time series neural networks to predict when you'll arrive home. Air purifier. Reinforcement learning adjusts fan speed based on air quality feedback. Smart water heater. Smart water heater learns your hot water usage patterns to preheat efficiently. Smart speaker. Natural language processing neural networks understand your voice commands. A smart lock. Behavioral biometrics learn how you unlock your door. And your smart fridge. Computer vision identifies food items, predicts when you'll run out, and suggests recipes based on what's inside. All right, so the next thing is transportation neural networks. All right, where machine learning becomes life and death. So we have automatic emergency braking, real time neural network. Your car's automatic emergency braking runs multiple neural networks in parallel. This is almost similar to ABS as well, right? Your automated braking system. But this is automatic emergency braking. One network processes camera data, another handles radar, and another LIDAR, LIDAR. They're trained on millions of driving scenarios to recognize that object ahead is decelerating fast. These networks run inference, meaning they process new data through their trained model in milliseconds. And when they detect danger, they override you. That's an AI agent with veto power over human decisions, pretty much. All right, the next one is adaptive cruise control. This is a reinforcement learning agent. Modern ACC or adaptive cruise control uses reinforcement learning where the agent got rewarded during training for maintaining safe distances while maximizing efficiency. It learned to predict, will that car ahead brake? Should I slow preemptively? It's not following fixed rules, it's just applying a learned policy from training data across millions of miles. Lane departure warning, number 15. Computer vision plus prediction. Your lane departure system combines computer vision neural networks to detect lane lines with predictive models that forecast your vehicle trajectory. It's not just seeing the lanes, it's predicting where you're going based on steering, angle, speed, and learned driving patterns. When predictions cross boundaries, alert. Number 16, parking assist. SLAM plus path planning. Parking assist uses the same SLAM technology as your Roomba, combined with path planning algorithms from robotics research. It maps the space, identifies obstacles, plans an optimal path, and executes precise steering, all autonomously. Number 17, traffic light systems, optimization neural networks. Modern traffic lights use neural networks trained on traffic flow data to optimize timing. They learn patterns, rush hour congestion, event days, and weather impacts. They're making real-time decisions. Extend this green light 10 seconds, traffic is heavier westbound. That's autonomous city scale optimization. All right. And you have number 18, automatic toll collection, computer vision agent. Easy pass cameras or even HOV lane cameras, depending on what state or what region of the world you're in. We'll just say easy pass cameras use convolutional neural networks for license plate recognition. Trained on millions of plate images in different lighting conditions, angles, and speeds. It processes your plate at highway speed, matches it to account charges correctly, all through machine learning powered computer vision. All right. Next up, we have digital AI agents. Your digital life is orchestrated by invisible agents. Number 19, email spam filter, multi-layer neural network. Gmail spam filter is a deep neural network, meaning it has many hidden layers processing your email. The first layer analyzes word patterns. The second layer, sender behavior. The third layer, link destinations. And the fourth layer, timing patterns. Each layer extracts increasingly abstract features, just like how your brain processes images. It was trained on billions of emails, learning what spam looks like through supervised learning, where humans label examples as spam or not spam. Right? So all these things that we do in our email, just all of our actions, all of these things, as you can see, are being timed and measured and basically trained into systems that we use on a daily basis. All right. Number 20, the social media algorithm, everybody's favorite recommendation engine. Instagram's algorithm is a massive neural network running collaborative filtering and deep learning. It learned by analyzing billions of user interactions. Who watches what? For how long? What did they watch next? It uses transformer models, the same architecture as ChatGPT, to understand context. Users who watch this also engage with that. Every time you scroll, it's re-ranking content through real-time inference. Thousands of posts competing for your attention, scored by neural networks predicting your engagement probability. Number 21, streaming recommendations. Deep learning agent. Netflix uses deep learning with multiple neural network architectures. Collaborative filtering learns users like you watch these. Content-based filtering analyzes this show has these attributes. Then it combines both through a deep neural network that learns optimal weighting. It's not one algorithm, it's an ensemble of machine learning models or ML models working together. 22, voice assistants, NLP neural networks. Alexa and Siri use multiple specialized neural networks. One for wake word detection, one for speech to text conversions, one for natural language understanding, and one for intent classification. When you speak, your voice flows through this entire pipeline of neural networks, each trained on massive data sets working together to understand intent and generate responses. All right, and we're going to go through a few more. So, 23, auto update systems. Auto update systems use reinforcement learning to optimize installation timing based on your usage patterns. It learned when you're not using your computer. Cloud backup, similar to Dropbox or Google Drive sync status. Cloud backup agents use neural networks to predict which files you'll need next, prioritizing sync. It's not backing up randomly, it's predicting based on your work patterns. Password managers. Password managers employ anomaly detection to identify suspicious login attempts. New device, different location, different time of day, flags it. Number 26, ad blockers. Ad blockers use trained classifiers to distinguish ads from content, constantly retraining on new ad formats as advertisers try to evade detection. Number 27, predictive text. Predictive text uses recurrent neural networks that learn language patterns from billions of sentences. It's predicting what you'll type based on context. Video call quality. Video call quality, neural networks dynamically adjust bit rate based on bandwidth predictions. It's forecasting your connection quality milliseconds ahead. Next up, we have health and finance machine learning agents, making decisions about your body and your money. Credit card, number 29, credit card fraud detection, an anomaly detection agent. When you swipe your card, it triggers a fraud detection agent using anomaly detection algorithms. This neural network was trained on your specific spending patterns using unsupervised learning. It learned what's normal for you without being told what fraud looks like. It computes an anomaly score in real time. Does this purchase match this user's embedding vector? If the score crosses a threshold, blocked. That's machine learning, making financial decisions in milliseconds. And I would also say, even if you set limits, if you have different limits, like Cash App has limits, right? The minute that you send a transaction, even Zelle, any of these accounts, if there are limits set on how much you can spend in a day, a week, a month, as soon as you hit that limit, it's over, right? Same thing or similar. Number 30, fitness tracker. Time series neural network. Your smartwatch runs a specialized neural network called an LSTM, or long short term memory network, designed to process time series data. It's analyzing your heart rate patterns across time, learning what's normal for you during sleep, exercise, and rest. It maintains memory of past patterns while processing new data. When it detects an irregular pattern, it's not following a rule. It's comparing new data against its learned model of your specific physiology. 31. Medical monitors, predictive healthcare agents. CGMs, or what they call continuous glucose monitors, use machine learning to predict blood sugar trends 30 minutes ahead. They analyze patterns, food intake timing, exercise effects, sleep quality. They're not just measuring, they're forecasting using trained models, enabling proactive intervention before dangerous events occur. All right? We have a few more in health and finance. Investing rebalancing, number 32. Investment rebalancing agents use reinforcement learning to optimize portfolio allocation based on market conditions. It learned trading strategies through simulated trial and error. 33. Insulin pumps. Insulin pumps employ predictive models to adjust dosing based on learned metabolic patterns. It knows your body's insulin response. 34. Sleep trackers. Sleep trackers use neural networks to classify sleep stages from movement and heart rate data, trained on thousands of sleep studies. 35. Medication reminders. Medication reminder apps learn your routine and optimize reminder timing for maximum adherence, not just random reminders, strategically timed. Of course, I would say also, you're probably going to input something. You may set the reminder, but eventually, depending on what type of app you're using, it just depends on whether or not you're inputting it or whether you're confirming you did something or not. And then from that, it's still learned behavior. It's still coming in and pretty much optimizing that timing. So the machine learning process, here's how these agents learned. Number 1, show the network millions of examples. Number 2, it makes predictions. Number 3, it calculates how wrong it was. Number 4, it adjusts the weights to be less wrong. And number 5, it repeats millions of times. That's how your thermostat learned your schedule, by being punished for wrong predictions until it got better. And more than likely, the wrong predictions probably happened in testing before you even got the thermostat or before the thermostat came to market, but also it could probably still happen in regular setting, but it's probably more efficient after they've done all the testing. The same way how they test cars, they bring them out. To crash dummy test. They got to do all the things, put it through, like the commercials when you see them riding through all the terrains and doing all the crazy stuff with the cars and the trucks. How Toyota Tacoma used to drop the truck off the edge of a mountain just to see if it was going to land. Those different things. Same type of learning behavior or the same type of information that they're trying to get to see what the vehicle will do or to see what these devices will do. All right. So transformers and key terms. So the newest evolution, transformers, this is what powers ChatGPT and many of your agents. The key innovation, self-attention. The ability to look at all parts of the input at once and decide what's important. Your email filter uses this to understand context. So you have reasoning, thinking through problems step by step. You have parameters, the knowledge stored in weights, billions of them. You have inference, applying learned knowledge to new situations. You have embeddings, concepts represented as numbers. And you have reinforcement learning, learning through trial and error. All right, so we're not living in the future, okay? You're living in an AI powered present where machine learning agents trained on neural networks are making hundreds of micro decisions about your life every single day. Now, of course, we may be in the future of time, what something used to be, but thermostats have been around for a long time now, right? Well, long enough, okay? Cars have been around for long enough, right? And planes and things of that nature. And they all have systems and things that come together to make sure that even their calculations and their predictions and their radars are receiving the right information to keep them on track as well. So this has been going on for generations at this point. The question isn't whether AI will be part of your life. It already is. The question is, are you going to understand how it works or what it is that's working around you? If you want to be one of the people who actually gets this stuff, hit subscribe, drop a comment with which agent shocked you the most, and share this with someone who thinks AI is coming soon. Tell them it's already here. It's just hidden in plain sight. I'm Allison Jones, your host and your guide through API World Covered, and this was another episode. You can check out all the previous episodes as well. That will also help you learn more about what's going on around us and what we're connected to already. All right, peace.